Today, we're going to look at a trinomial square, which is an expression with three terms inside parentheses raised to the power of 2. Here we have a plus b plus c, all squared. Let's focus on this exponent 2. When we see a squared term like this, it's telling us to multiply the entire expression by itself once. So we can rewrite a plus b plus c squared as a plus b plus c multiplied by a plus b plus c. This is exactly what the exponent 2 means, to use the expression as a factor twice. Notice that both factors are identical. We're literally taking the original trinomial and multiplying it by itself, just as we would when squaring a number like 5 squared equals 5 times 5. This relationship between a trinomial squared and the product of two identical trinomials is a key algebraic identity that appears frequently in mathematics. While this form helps us understand what squaring means, we'll need to use the distributive property to fully expand this expression and collect like terms. Now that we understand that a plus b plus c squared means multiplying a plus b plus c by itself, we're ready to see what happens when we actually perform this multiplication. Let's explore how to expand the trinomial square, a plus b plus c squared. This is similar to expanding a binomial square, but with 3 terms instead of 2. Remember that any expression squared means the expression multiplied by itself, so we can rewrite a plus b plus c squared as a plus b plus c multiplied by a plus b plus c. To apply the distributive property systematically, we'll set up the first factor on the left and the second factor on top. This visual arrangement will help us keep track of all the multiplications we need to perform. When distributing with trinomials, we need to multiply each term in the first factor by each term in the second factor. To organize this, we'll create a 3x3 grid with 3 rows for the terms in the first factor and 3 columns for the terms in the second factor. We'll label each row with a term from our first factor, a, b, and c, and we'll label each column with a term from our second factor, also a, b, and c. This grid helps us ensure we don't miss any multiplications when applying the distributive property. Let's identify the individual terms in our first factor and connect them to the corresponding rows in our grid. The a term will correspond to the first row, b to the second row, and c to the third row. Similarly, let's identify the terms in our second factor and connect them to the corresponding columns. The a term will correspond to the first column, b to the second column, and c to the third column. Each intersection in our grid will represent a multiplication of one term from each factor. Now we can fill in each cell with the product of its corresponding row and column terms. For example, the top left cell will contain a times a, which is a squared. The middle cell will have b times b, or b squared, and each other cell will contain the product of its respective row and column terms. This completed grid shows all 9 terms that result from fully distributing a plus b plus c times a plus b plus c. We have a squared ABAC in the first row, BAB squared BC in the second row, and CACB C squared in the third row. Each cell represents one term in our expanded expression. The expanded form of a plus b plus c squared is the sum of all these 9 products. Written out, we get a squared plus ab plus ac plus ba plus b squared plus bc plus ca plus cb plus c squared. Notice that we have terms like a b and ba, which are actually equal since multiplication is commutative. We can simplify this expression further by combining like terms. For instance, a b and ba are the same, so we could write 2ab instead. Similarly, ac and ca give us 2ac, and bc and cb give us 2bc. After combining these like terms, we would have a squared plus 2ab plus 2ac plus b squared plus 2bc plus c squared. The grid method we've used is a powerful way to visualize the distributive property for trinomials. It ensures we account for all terms when expanding expressions like a plus b plus c squared. This same approach can be extended to multiply any 2 polynomials together. Here we have the expression a plus b plus c times a plus b plus c, which is the trinomial squared. To expand this expression systematically, we'll use a multiplication grid to organize our work. When expanding, using the distributive property, we'll multiply each term in the first factor by each term in the second factor. Let's start by highlighting the first term a in red. This represents what we'll multiply across each term in the second factor, which is highlighted in blue. Our grid helps us organize this multiplication. The red A appears on the left side, showing what we're multiplying with. Across the top, we have the blue trinomial A plus B plus C. Each cell will contain the product of the corresponding terms. For the first row of our multiplication, we need to distribute the term A across each term in the second factor. This is where we apply the distributive property. A times the sum of terms equals the sum of A times each individual term. Let's start with the first term. When we multiply A times A, we get a squared. This follows the basic law of exponents, where multiplying the same variables adds their exponents. We place a squared in the top left cell of our grid. This represents the first product in our expansion. Notice how the color purple helps us track this result as coming from our red and blue terms. Moving to the second term, we multiply A times B. Since these are different variables, the result is simply the product AB. We can't combine them further because they represent different quantities. We place AB in the middle cell of the top row. This is our second term in the expansion. The ordered pair of variables tells us exactly which terms from the original expression were multiplied together. For the third and final term in this row, we multiply A times C to get AC. Again, since these are different variables, we simply write their product. This completes all the products involving the first term A from our first factor. We place AC in the rightmost cell of the top row. Now we've completely distributed the term A across all terms in the second factor, giving us a squared AB and AC. Adding these products together, we get a squared plus AB plus AC for the first row. This represents 1/3 of the total expansion of our trinomial square. Each term comes from multiplying the first term A with each term in the second factor. With the first row of our multiplication grid complete, we've found 3 of the 9 terms in our final expansion. Notice how this systematic approach helps us keep track of all the products without missing any terms. Let's continue our expansion of the trinomial squared, specifically a plus b plus c squared, by examining the second row of our multiplication grid. This grid represents our approach to expanding the trinomial squared. Each cell will contain the product of a term from the left column with a term from the top row. In our previous work, we completed the first row by multiplying A with each term in the trinomial A plus B plus C, giving us a squared AB and AC. Now we'll move to the second row, where we'll multiply B by each term in our trinomial. This follows the distributive property, where B multiplies each term inside the parentheses. We'll work systematically, multiplying B by each term in the trinomial and placing each product in its corresponding cell in our grid. First, we multiply B by A, which gives us BA. Since multiplication of variables is commutative, BA equals AB, but we'll write it as BA to keep track of which row we're working with. This product goes in the cell where the B row meets the A column. Next, we multiply B by itself, giving us B squared. This is the second term in our row and represents the square of the middle term in our original trinomial. It goes in the intersection of the B row and B column. Finally, we multiply B by C to get BC, which completes our second row. This product goes where the B row intersects with the C column. Combining all these terms, we see that the second row of our expansion is B times A plus B plus C, which equals BA plus B squared plus BC. This is a direct application of the distributive property. At this point, we've completed 2 rows of our expansion. Notice how each row represents one term from our original trinomial being multiplied by the entire trinomial. This systematic approach helps us ensure we don't miss any terms in the expansion. Our grid is gradually filling up with all the products needed for the complete expansion of A plus B plus C squared. In our next step, we'll handle the third row by multiplying C with each term in the trinomial. Let's continue our work with expanding the trinomial square. We have the expression a plus b plus c all squared, which we can write as a plus b plus c multiplied by a plus b plus c. In our previous work, we tackled the first part of the expansion. We multiplied a by each term in the second factor, giving us a times a plus b plus c. When we distribute a, we get a squared plus ab plus ac. This follows from the distributive property, where we multiply a by each term inside the parentheses. Next, we expanded the second part, where we multiply b by the entire second factor a plus b plus c. When we distribute b, we get ba plus b squared plus bc. Notice that ba is the same as ab from our first row, since multiplication is commutative. Now we need to complete our expansion by handling the third part. Here, we'll multiply c by each term in the second factor, a plus b plus c, just as we did with a and b. First, we multiply c by a. Just like when multiplying any two variables, we get ca, which is the same as a c due to the commutative property of multiplication. Next, when c is multiplied by b, we get cb. Again, this is equivalent to bc that we found in our second row. The order doesn't matter in multiplication. Finally, when c is multiplied by itself, we get c squared. This follows the same pattern we saw with a squared and b squared in our previous rows. To complete our expression, we need to add the plus signs between these terms, since we're summing the products from our distribution. Our completed third row shows c times a plus b plus c equals ca plus cb plus c squared. This is the final piece we needed for our full expansion of the trinomial square. Looking at all our expanded terms, we can observe a pattern. The diagonal terms are the squared terms, a squared, b squared, and c squared. These come from multiplying each term by itself. We also have pairs of equivalent terms due to the commutative property of multiplication. The term AB appears the same as BA, just written in a different order. Similarly, a C and CA are equivalent terms. And finally, BC and CB are also equivalent. When we combine like terms in our final expansion, we'll add these pairs together. We've now successfully expanded the third term of our trinomial square. This gives us all the pieces we need to write the complete expansion of a plus b plus c squared. Let's start with our full expansion from multiplying out the trinomial squared. When we expand a plus b plus c squared, we multiply each term in the first parentheses by each term in the second, resulting in these 9 terms. Looking at our expansion, we can see several pairs of terms that appear to be the same value. Let's identify and combine these like terms, starting with a b and ba, which are highlighted in yellow. Since multiplication is commutative, a times b equals b times a. This means that we can add these two identical terms together, giving us 2ab. This is our first combined like term. Next, let's look at the AC and CA terms, which I've highlighted in orange. Just like before, these terms represent the same value due to the commutative property of multiplication. Since a times c equals c times a, we can combine these terms to get 2ac. Notice the pattern that's forming as we simplify our expression. For our last pair of like terms, let's focus on BC and CB, which I'm highlighting in purple. These two terms are also identical in value because of the commutative property. As expected, b times c equals c times b, so combining these terms gives us 2bc. We've now combined all the pairs of like terms in our expansion. Now that we've combined all like terms, we can rearrange our expression into standard form. The standard form typically begins with the squared terms followed by the cross product terms. In standard form, we first list all the squared terms, a squared, b squared, and c squared. Then we include all the cross product terms, 2ab, 2ac, and 2bc. This arrangement makes the pattern clearer. So our complete expansion of the trinomial squared, a plus b plus c squared equals a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. Notice how this follows a pattern similar to the binomial square, but with additional cross product terms. This formula is an important algebraic identity. Each squared term, a squared, b squared, and c squared, comes from squaring each term in the original expression. The cross product terms, 2ab, 2ac, and 2bc, represent the product of each possible pair of terms, multiplied by 2. To summarize what we've learned, when expanding a plus b plus c squared, we get the sum of the squares of each term plus twice the product of each pair of terms. This pattern can be very useful when working with more complex algebraic expressions.